How you doing, everybody? Can I hear a good? Come on. All right. Yeah, let's get some life in here. So we're going to tell you a little bit about our journey into Kubernetes and how we went from learning how to pronounce it, to production in about 3 months' time or so. We're from GolfNow, which is a branch of Golf Channel, which is also a branch of NBC Sports, and it keeps going from there, and I'm going to spare you all those details. So who are we? I am Mohamed, Director of Architecture on GolfNow. Been with the company 7 years. Actually, today is my 7-year anniversary. Yeah, there you go. Thank you. Josh Chandler, Senior Software Engineer on the architecture team as well. He's been 2+ years about. So, yeah. So what do we do at GolfNow? We are an e-commerce platform for tee times. We sell tee times for military, things like that, for nice discounts, obviously, for them. We have our counterparts in Europe called Tee Off Times. We also have a Groupon-like application called Deal Caddy to sell golf clubs, gloves, things like that. We also help with the operations, point of sale for the golf courses, electronic tee sheets. We help courses that are mom and pop shops all the way up to resorts with their operations there. We also offer services like phone answering services 24/7, 365. We also help them with bulk purchasing of their products, things like that. Basically the focus of our services is really to get the golf pros out in front of the customers that are actually there, that are about to golf and tee off. So we've been growing like crazy. We've, I think, bought about 10 companies or so in the past couple of years. So it's been awesome. So that takes us into growth is awesome, right? We're making tons of money. You've got people popping up from anywhere and everywhere, even from places you don't even realize you would have. And everybody's high-fiving each other. Sales team is like, yeah, we're killing it and everything, and it's great. However, on the technology side, we're thinking, wait a second, growth is hard. We got to deal with 20+ second page load times, making sure our website is up and running, our infrastructure is getting hammered, things like that. Sleepless nights, of course. So with all that, we actually went through a lot of redesigning our code. We had a lot of issues with our code, stored procedures not being very efficient, so we fixed a lot of that stuff. So a few months after that, Steve, our sitting down in the corner over there, VP of Technology, comes to me and says, I want you to make a platform that is geo-load based, and if a data center goes down, the user doesn't notice. Go. I'm like, all right, awesome, yeah, we could do that, not a problem. And then a few seconds later, it kind of sunk in. I'm like, wait a second, what? What do I got to do? And just kind of calmed down from there, realized, all right, well, what were our pain points? Why did he ask to do this? Why do we want to do this? We just fixed a ton of code, right? But we were still growing. There's still a lot coming down the pipe for us. And we needed to do something else. We needed to learn how we could scale in a much more efficient way so we could actually sleep. Because we went for about 2 to 3 years, 4 years or so, not sleeping at night when our infrastructure was getting hit pretty hard. So the lay of the land of when we started looked a little bit like this. Well, we were West Coast data center only. Then we had a DR over on the East Coast. And then we had a one-way data sync that would happen every 15 minutes or so. And it was great, but the problem was that we'd have to build an identical data center. So that means double the cost, double the time of deployment, double the time of test. Then it's become a reactive thing, not a proactive thing. So if the data center on the west goes down, we have to scramble for a couple hours or whatever the case may be to make sure east is okay. So that was at least the lay of our infrastructure. Then our application. It was a monolith. It was the textbook example of reusability that you learn in computer science. So it shared everything. The problem with sharing everything is that when we made a change, as you all know, it would be a huge ripple effect across everything in all our systems, which means we'd have to test everything all the time, all over again for every release, which means our cadence for releases were a lot slower. So from there, we knew that we needed to break it apart. So we wanted to go towards more of a microservice architecture, of course. We wanted to be able to, when something goes down, and yes, I made it a database, we wanted where something went down, it would just heal itself. And if we had a lot of hits coming against us, we wanted to be able to auto-scale on its own. So we wanted it to kind of know our infrastructure and our traffic structure so that it would auto-scale for us. So at this point, after kind of knowing at a high level what direction we wanted to go, we knew that we wanted to go containers, Docker, and all these things. But the problem was containers and Docker were great at a local level. Dev machine, Josh and I passing containers back and forth, it was awesome. Made things a lot easier in that sense. However, we had a lot of questions. How is this going to go to production? How will this scale? How are we going to schedule this? How do we make this so that we don't have to deal with waking up to make sure a pod is always running? So we did a lot of research. A lot of things we looked at were Panamax, Fleet, Swarm, what's another one? Deis, yeah, we looked at a couple of different ones. Mesosphere actually in DCOS. But then we stumbled on this thing called Kuber or something or other. And we were like, okay, this seems kind of promising. And at this point, when we discovered Kubernetes, this was about, I think, September of last year. It was a 1.04 or 5 version. And we realized that this is probably the direction we want to go. We were really heavy on Mesos. We were about to go in that direction. However, we noticed that it wasn't as easy for us to be able to put it in different cloud providers if we wanted to. We were pretty much stuck in AWS, at least at that time. We were pretty much stuck in AWS with DCOS. So we wanted to be able to make it so that we could go in GCE, AWS, private, wherever. And Kubernetes kind of gave us that light. It gave us that ability, and we kind of shifted gears from there. And at exactly around that time, we had this battle between Kubernetes and Cloud Foundry. We kind of were tasked with, okay, go ahead and build out a Kubernetes cluster, and another team was building out a Cloud Foundry cluster to kind of see at the end of about 3 months or so what is going to be more production ready, how can we use it, and things like that. So as we were going through this journey, we realized towards, 2.5 months or so into it, Cloud Foundry wasn't going to work for us, for our particular use cases and the way we wanted to use it. We wanted it to be able to run Docker, because we had already containerized and Dockerized a couple of our applications as it was at that time. And we wanted to actually go a level deeper and containerize our data tier, which was crazy at the time, but we wanted everything to be the same, essentially. So at the end of the 3 months, we had a production-ready, pretty much Kubernetes cluster, and that's when Steve came to us and was like, okay, great, POC, that's awesome, but let's now put your money where your mouth is, and let's start doing something real now. So it took us to this point where we had bought a company called T-Leader that was going towards this microservice architecture using Node.js, MongoDB. So it was kind of going in the direction that we wanted to go to anyway. But it was all running on Heroku, Compose, and a bunch of other third-party services for the data tier and everything like that. So it was a perfect candidate for us to bring over into our new platform that we were building. So I'm very competitive and a little crazy, I guess, and I wanted to prove that this new platform is definitely the way we want to go. And it's the wave of the future for us. So I wanted to prove that we can do this in the middle of peak hours when we're actually making money on the system, and start with the database first. So kind of got a little bit of pushback on that, but Steve trusted us and he went with us. So we ended up moving the databases one at a time over about a week's span. Obviously, when we moved one, we'd make sure everything was running, let it run for a couple days, and then move the next, and so on. So it took us about a week or so. And nobody noticed, which was awesome. Obviously, the only person that really knew were really the two of us and a couple other engineers that worked with us, and Steve, because we had to tell him, obviously. So we kept gaining confidence, kept going from there, started moving our RabbitMQ queuing service, our Redis, and just kept going from there. And in about, I think it was like a 2 to 3 week time frame, we moved the entire infrastructure that was running third-party SaaS over into our new platform that's actually running in GCE. And no, not GKE, because I've had that question many times. So life was good at that point, but that didn't really solve the complete requirement that was given to us at the beginning. So this was just proving out that we could have these different clusters all around the world. So we had this in one data center. Then now we had to get into designing how would we geographically distribute all this data. Now, obviously, we could go the easy way and use Mongo's replica sets across the globe and let it do its thing from there, and we'd be done. However, we didn't want to marry ourselves to one particular data store because everything changes and it's constantly going and moving forward, and we want to be able to move forward with it. We don't want to be stuck anywhere. So we needed to devise a different way of moving all this data around. So what we came up with was, let's put Kafka on top of all of this. Let's have a service that can watch the op log on whatever data store that we use and basically take that op log and push it up to Kafka. And then from there, we could use Mirror Maker and move all the operational logs basically all over the globe, all over to the different data centers that need that data, who does not have that data, because the data originates from a particular data center and then has to move across to the others. So with this, we're able to now keep everything eventually consistent, which is what a lot of the data stores do for us anyway. And then the beauty of it is, as well, is that we can go and change a database engine in any one data center if we wanted to, although it's probably not recommended to do so. But if we wanted to, we could. As long as we change that service that's interacting with the database, we should be fine from there. And I'm going to pass it over to Josh now to talk to you guys a little bit about our software development lifecycle.
Hi, everybody. I recently came down with the presenter's flu, so apologies for that. So after day 2 of KubeCon, I'm sure this is going to be kind of a familiar workflow to most of you, but we'll just walk through this very briefly. So the lifecycle starts, of course, with any engineer that wants to make any kind of change to anything. In fact, you'll probably see some of these messages popping up as we go through our demo, which we're going to do in a second. As soon as somebody pushes to GitHub, we have a set of webhooks back there that allow that code to be pushed to our CI/CD pipeline. In this case, we're using Jenkins. In fact, we use Jenkins as sort of a hive mind for our deployment infrastructure, as you'll see in just a minute. Jenkins' first order operation is to build that code and do an automated test, whatever that may be. npm install, go build, run the automated test and make sure it succeeds. If in fact it does, then we'll have a Docker build and it will deploy straight out to key.io, our container repository. And then on the completion of that operation, we'll push that out to a staging Kubernetes instance that we have. After that's done, we'll have Jenkins file a ticket on our ticket tracking system, Jira, which will inform a QA engineer, hey, go check this out, we just made a change. So they'll be informed as such, they'll interface with that code. out there in the QA Kubernetes cluster. They'll sign off on the ticket. That pushes back to Jenkins that, hey, mission complete. And then we will roll that out to production Kubernetes cluster. Currently, we have it at a push of a button. We could make this automated if we wanted to. It doesn't really matter. We're just kind of trying to get things off the ground. So with that, I'm going to show a very brief CI demo. All right. So just to kind of show you what we're working with here, we wrote a little toy application called Toybox. Oh, so sorry. Thank you. There we go. So there's really not much to Toybox. It's a toy. It really just counts hits. That's what you see here. So every time you go to the page, it'll count a hit and log it back. And of course, you can see we've got all that version history and stuff like that. We have that this is QA. In fact, we have 2 builds of this. One is running in our staging instance. The other one is running in our production infrastructure. It's the exact same code. And it does the exact same thing. Before I get into the demo, I just kind of wanted to give you an overview of what this Jenkins stuff looks like. So we kind of haven't gone the whole Jenkins file route yet. We did just recently up version to Jenkins 2. And we are using pipelines. But we kind of got things distilled down to a whole, just tell me kind of what you want. Want to interface with a cluster? Okay, great. Here's your configuration for it. We have things about the tooling that you need to build out things, environments that you want to use, source control management. One day, maybe we won't be on Git. We may want to change that over. So we've done this and flattened this view out across most of our build properties, and it's worked out very, very well for us. We're really happy with it by and large. So with that, let's start our demo, which again is hiding off screen. So Toybox isn't great, because what if I were to, say, hit it with some process that could generate thousands and thousands of requests a second, and that wouldn't be very good or very true. So what I'm going to do to that end is first switch to our QA cluster. Sorry, I can't type. Let's do 20. So if we flash back to the application, as those pods start to spin up, I just scaled up this requester module that's just making essentially curls against it over and over again. And you'll see that the traffic is kind of spiraling out of control. And that's not very good. Just to up the ante on that too, I'm going to do the exact same thing in production, because demo gremlins, never happen. And it would also kind of be nice to see what transpires when we do this rollout. Okay. So the thing I'm going to do here is put in some Redis. And that's going to be it, to do some rate limiting over the top. It's one thing that we really, really like about our microservice architecture insofar as everything is so easy, so smooth. In fact, when I wrote this out in the first place, before I did all this syntactic sugar over the top of this process, it really took 5 minutes to put it all together, which is something I don't think we could say for our traditional monolithic builds. So this is just a simple happy JS server. I'm going to change the version to 2. I'm going to add it. Commit, and I'm going to push it. So one thing I neglected to mention looking at that Jenkins config is we very meticulously log our CI. Everything that happens in that process, we're looking over it the entire time. Once that webhook actually picks up, you're going to start seeing the messages coming through here that it's actually doing its build, and there it goes. We have kind of moved away from actually talking to Jenkins directly. So lately we've been kind of getting into the whole chat ops thing and building out bots. And in fact, instead of going into Jenkins to finish this all out, I'm going to talk to our bot. His name is Rick Jenkins, and he's essentially our interface into Jenkins itself. And I'll talk a little more about where he came from here in just a minute, but that build is completed. I'm skipping over a couple of things. Hand waving. Oh, I'm so sorry. Again, my apologies. So all that stuff I just said, repeat. This is our logging process right now, really very intense. So here's our bot. So I'm going to tell the bot to please deploy the build for CanIO. Toy box. Oh, he didn't understand. Although it's probably because he's so far away. There we go. And spelling's not my strong suit. So there he goes. If you look over here at Toybox, you'll notice the request traffic is really tailed off. The deployment happened to the QA cluster just like that. And commensurately, you're going to see the exact same thing over here on the production edition. We're taking a whole lot of flack right now, a lot of traffic as the rolling update occurs. But give it a little bit of time, and suddenly we get this super cool edition instead. The exact same here, same thing here for QA. So, before I let Sharif take back over,
Okay.
I was going to talk about some of our supporting application infrastructure. When we came into this, we, as Sharif mentioned, we inherited that company T-Leader, and they came from Heroku. Heroku's got all of its nice features and things like that, so we kind of wanted to get those things off the ground in Kubernetes as well. One of the first things we did was a higher fire equivalent that we call Quisin, which is essentially responsible for monitoring queues and monitoring RabbitMQ queues, their sizes, and then scaling them up when the time comes. So we have settings that are quite a bit like higher fire insofar as that goes. We use Pingdom a lot internally to monitor our applications. We wanted a way to look at things like MongoDB and Elasticsearch semantically. So instead of just saying, can I get to this thing? Can I do DNS lookup? It's not enough. We wanted to see something that's more about, the semantics of how that application works. I should be able to log into a Mongo cluster, run some query, get a result back, and everything should work out from top to bottom there, which Pingdom doesn't really give you that right out of the box. So we wrote an app called Fief, and it does exactly that. We have interfaces for MongoDB, for Elasticsearch, for RabbitMQ itself, as a matter of fact. As I said before, we're getting into chat ops and things like that. So the Rick Jenkins bot that you saw a second ago is built on top of a framework that we are calling Amy. That thing is really kind of meant to abstract away the concepts of, your particular API. We kind of wanted to do like a WhoBot thing, but for the new age of Slack. So this Amy framework is something we're hoping to open source in the near future. So we have a Twitter handle for this, at Real Rick Jenkins. If you want to follow us along, we think it's a really great project, and you'll really get a whole lot out of it. What else? We've been doing backups of our entire cluster. We've written a lot of things to be able to just kind of snapshot the state of things, push it into buckets out there in GCE. That's been very good. In fact, we've saved ourselves numerous occasions by, we just obliterated this object. What are we going to do? Let's go out to the bucket and just replicate it. And then there you go. Or if we want to replay in a particular cluster, we can do that. One very big thing we did with our cluster was we were trying to get some geo service data that we were paying for. It was very expensive, very prohibitively expensive. We wanted to sub that out. We were tasked with doing that. And in about a week with this microservice architecture, we were able to get one of these services off the ground with our own data store, saved a lot of money, and we're able to survive July 3rd, our worst day. Like the darkest day of golf is July 3rd for people in our industry. So with that, I'm going to hand this back over to Sharif.
Thanks, Josh. So we're going to talk about a little bit of our lessons learned, what we've done, what we wished we hadn't done, that kind of stuff. So one of the big things, as Josh mentioned, the chat bot that we created, we were trying to create a UI. However, because the dashboard just wasn't there yet. It was the early version of the UI. It didn't have deployments and all that stuff. So we were going to start trying to create our own and give it back. However, we got beat out at the time with dashboard, and we thought, okay, no problem. So we started using that a little bit. But then we wanted to even go a level deeper, and that's what kind of this chat bot came up and discussed it, and Josh was able to hack it out in a weekend, which was great. And it's been working very nice for us. Now we just pull out our phone, builds and deploys from our Slack apps. And we have roles and everything in it so that somebody who shouldn't be deploying or building are not going to be able to. The bot will just tell them you can't do that. So that's been great. So that's been a big lesson learned for us. Another lesson learned for us is at the very beginning when we first started, we wanted to have a production cluster and a QA cluster. We understood the point of namespaces and all that good stuff. However, since we had to be PCI compliant, we weren't sure how that was going to go over with all the auditors. So we figured, okay, let's just separate them completely, even physically. So when we started out with that, unfortunately, we used the kubeup script at the time. And we didn't realize that the kubeup script is only going to create one subnet for you to run the cluster. So we went and spun up the second one. It was on the same subnet. So we were load testing, playing around with this thing, and we were getting dropped packets, 20-second load times. Like, what the hell is wrong with this community? Why do they all like Kubernetes, man? This thing is not even working. So one morning, woke up in a cold sweat, had this epiphany. It was like, let's kill this other cluster. Because after digging deep into networks, how the networking worked, I realized that it may be this. So we killed the cluster. And as soon as that happened, the thing was snappy. It was quick. It was just back to the point where, like, okay, now we get it. We get why everybody loves Kubernetes as much as they do. So we had to fix the kubeup script from our perspective to create a new subnet for us when we did deploy it into GCE. At the beginning as well, because we had started off with C#.NET, everything was in C#, and today there still is a lot in C#.NET. There was no .NET Core, there was no containerization of that language. So we're trying to work towards that. So that's been kind of a long-winded lesson learned for us. We're still working through it now. We actually have a few engineers on the core team that are actually starting to rewrite a lot of our services to utilize that. And then there was this one day we were trying to use ABAC, the ABAC plugin, so we could have authorization. And this person, don't want to name any names, this idiot wanted to try and do it on a production cluster. And what, man, you threw that slide in? That's not cool.
What? Did what?
Anyway, so yes, it was me, the idiot. I thought I knew what I was doing. Installed the ABAC plugin, tried to get it up and running, and brought down our entire cluster. And this was the production cluster, mind you. So this was part of my like crazy side where I just, I was being a little too ambitious. So with that, the great thing is that we had created a config backup mechanism that will take our entire Kubernetes infrastructure in JSON files output and put them into a bucket for us somewhere. That would run every 5 minutes. So the nice thing was, all we had to do was just go back to that bucket, pull it all down, and kube control everything. And we were back up within 20 minutes. And Steve had sort of noticed that something was up, but then by the time he had come and checked in on us, and we were already up and running. And then we had to tell him what happened, obviously, and tail between my legs and all that, Anyway, so I learned that at that point we needed a QA cluster and try not to use alpha applications within a production cluster. So with all that, I mean, the point is that a lot of the lessons that we learned were because we created problems for ourselves. And a lot of it was because of networking and things like that. So if you haven't had an issue with networking on Kubernetes, you have not used Kubernetes. You have not exercised it enough yet. So anyway, so that's our big lesson learned, I think, from there. So to wrap it up, I want to share some stats with you guys in this migration and how much we've actually done in such a short period of time. And really between 1.5 resources, because I was about half the time. Josh has been a lot of the time, full-time on it, and a couple ancillary developers that were helping us out. We're running about 200 plus services within all our clusters. We're running 4 clusters. We have a Golf Channel cluster, which Golf Channel is actually hosted through Kubernetes. We have a GolfNow cluster that's running some of this T-Leader, that's actually running all of the T-Leader application on, which is going to be kind of like a central microservice. Everything's going to move towards in that direction. And then we have a QA cluster, QA staging cluster, and the last cluster that we have is a cluster in the EU with our counterparts over there to also kind of get into all this. We're running about 30 plus different replica sets, MongoDB replica sets. These are all different clusters for different microservices. The idea that we had was for a microservice to be truly a microservice, you need to also make sure your database is essentially a microservice in itself as well. We have about 10 plus Elasticsearch clusters, 10 or so Redis. We have about 3 terabytes of managed data. And this is, again, running all our data tier within a containerized environment, ephemeral containers, all that good stuff. We're using, obviously, persistent disks within Google. And lastly, our lone Kafka cluster, which will grow based on the slide I showed you guys earlier with the geodata sync. But Kafka's been working great for us. Actually, another stat that I forgot to put in here was we have about two or three RabbitMQ clusters also to kind of federate a lot of our messages that are going all over the place. Again, so we don't have a single point of failure, all that good stuff. So with that, appreciate you guys listening to us. We have a few minutes. I wanted to open up the stage to some Q&A. Sure.
Yeah, so when you had that diagram of the geo load balance thing there, and capital stuff in there, does that presume that there aren't any overlaps in the domain of data that's being shipped around?
So the question was, is that in the geodata sync design that we have, does it assume that there's no overlap in the data? Yes, it does, because every data center is going to generate their own T times for that particular region. So we've got a European region that's going to generate those T times for the European region, and then that data is going to go across to the US. So if there's a person in the US that's going to be planning a trip over into Europe, their T times don't necessarily need to be minute by minute. They don't need to be there right away. They're going to probably be looking for 2 weeks, 3 weeks, a month, or a couple months out. So that data doesn't really churn as much as data that's going to expire soon with the T times that are coming up. So yes, it does assume that the data is unique that's being generated from all over the place.
What's the time it takes to replicate?
So through our tests, originally we wrote the service that pulled the data out of the op log and pushed it over. We wrote that in Node.js. And that was taking quite a bit of time. If I remember, it was taking 5 to 10 seconds, if I'm not mistaken.
That's about right, yeah.
And that to us was not going to be scalable. And it was running about, I think, actually, now the stat, let me bring it back. I think the stat was about 3,000 or so data points per second it was moving over. And that to us was not going to scale right. It was not going to work for us. It was going to start probably going lower, actually. So based on what we were looking at, what we were seeing as our traces, we noticed that it was actually Node that was causing the issue. Node was not able to keep up with that constant barrage of data because of its asynchronous nature and single-threadedness and all that good stuff. So we realized at that point Node is awesome, but Node is awesome for web-facing, consumer-facing type of deals. But if you're trying to do a lot of heavy lifting in the background, we went with Go. We tried Go. It was our first time ever using Go, and it was kind of like, all right, well, let's play around with Go, and we tried it. When we went with Go, the thing jumped up to like 10 to 15,000 a second. And it was literally our first application in Go. So there is plenty of room for us to be able to make it better and faster and all that good stuff. So at that point, we realized, all right, so all back-end heavy lifting type of applications need to be a lower level type of language, Go, C++, something in that nature. And then some more of like the consumer-facing APIs and websites should probably be JavaScript and Node.js. So. I'm sorry, I didn't understand.
How do you manage your clusters now? You're on AWS, GCE?
Oh, so the question was, how do we manage our database cluster, our clusters? It's in GCE right now. Our goal is to eventually get it into a private cloud. So the point was, like I said, was that we wanted it to be able to be lifted up and moved into any data center that we wanted, GCE, AWS, whatever, as well as private. So at the moment right now, we're only in GCE. The goal is to get it into private so that we can have the federation control plane to go in and out.
How do you provision an update on GCE?
So we use kubeup, the kubeup script. We just use what is in Kubernetes right now with the kubeup script. So yeah, I know there's kube ADM that we're actually going to try to exercise in our private cloud, and then further utilize it into our actual public clouds. Why not GKE, question? The reason why we didn't go GKE was, again, so that we're cloud agnostic, cloud provider agnostic. GKE is awesome. We actually played around with it. We used it. And the beauty of it was we didn't have to deal with the master, right? However, the point of us being agnostic to the cloud, it wasn't conducive to that. And again, it was just, again, to prove that we can actually go anywhere we wanted to. In the future, we may just say, all right, GKE for GCE, and then use our own homegrown into private, and then just have the Kubernetes Federation plane on top. So, and we're actually running 1.4 today, and we try to upgrade every half version. So next version is 1.4.5, which we're going to plan after this, and so on. Right, so the question was, what strategy are we using to upgrade the cluster, and have we looked into the kubeception stuff that Aaron Levy was talking about earlier? Yeah, self-hosting. We would like to get to self-hosting. We're not there yet, by no means. We're literally utilizing the upgrade scripts that are in the repository. I think we adjusted a few things in it.
We did.
To utilize it the way we wanted, so that it's a little safer. It gave us just the warm and fuzzies a little bit, I guess, as we were doing it. But it's basically the upgrade script.
Kubeception is definitely coming for us, particularly as we move into private clouds. With our environments in particular, they're extremely constrained. There's lots of strict rules about it, so bootstrapping is like the only way to go.
How do you run Elasticsearch clusters?
Painfully.
Not
like
pet sets,
many,
I can tell you that for sure.
Like a lot of the data tier, actually Elasticsearch is among the easier of those, but we run them as containers. I'm so sorry. The question was, how do we run Elasticsearch, whether it's pet sets, containers. So we run them as standalone containers. We've done a lot of clever hacking to get all of our data tier instances up and running. Elasticsearch was one of the easier ones to federate. MongoDB was the hardest, hands down, absolutely. I'm getting flashbacks right now, just thinking about it, as a matter of fact.
This was back because this was back way before pet sets, because we started at 1.0.4, I said, or 5, one of those two versions. So we had to make sure that it was always going to be able to come back, and it didn't. So
yeah, exactly. Stateful set's definitely the way to go now. It does seem like if we could go back and do it again, if we hadn't heaped on so much tooling as we have now, it probably would be one of those things. But yeah, we have taken a container approach to this point. And we actually, when we had been talking to Mongo at the time, and we had told them that we had done that, and they kind of were really scared. They're like, you can't do that. Like, oh, well, we did it, and we've been running it for like a year, and it's fine. So it seemed like we were one of the first to do that, at least that they've heard of. We haven't seen anybody running in replica sets in that manner. It took us quite a while to figure out how to do it, but now I think it's a Python script at this point, and it's very easy. We turn it up pretty easily now.
you want to take it or you want me to?
Sure. Actually,
Okay,
you want to start?
So the question was PCI, since we're PCI compliant, what kind of measures did we take to secure and everything? So we didn't do anything necessarily for the container to harden it or in any way, that shape or form. Actually, to begin with, because we had PCI on the mind, we were actually creating our own base images. This was basically unikernel before unikernel had a name. So we were trying to create it, and we were kind of building almost our own distro of what we needed exactly. So we went from the application and built it down from there and took the things that we needed. If it was whatever we needed for Go or Node.js or whatever the case may be, we built the base image from that. Again, for that security, to harden it as much as possible so that we don't have SSH, because we don't need it. We don't have USB drivers. We don't have any of this other fluff in the OS that we don't necessarily need. So we tried to harden it that way, but that was becoming more of a pain for us. And then the fact that we were using key and it giving us the security scans, we were like, well, maybe we're not doing it right. And we went back to just using a base Debian image. However, now looking back at it, maybe it was better for us to actually build our base images from scratch the way we were to make it a little bit more secure. Yes, we were losing the security scans. However, we knew what was in there for sure. And we could actually version control one distro, the image based on one version to another. So in that sense, we haven't done anything crazy, groundbreaking in that sense. What we actually did was just we made sure that our microservices that we created were all decoupled from the fact that the pods that were running within the data center did not process any data as far as credit cards go. And everything was offloaded to our PCI zone, which was on the West Coast that it showed in the diagram. So it's kind of like what we did. We just basically just made it so that there's a transparent redirect in the background that takes care of all of that for us so that the security concern is kind of offloaded into our PCI zone. Does that answer your question?
Can
Right. We don't have default service accounts that have access to everything. We create a new one for each service. And if it needs access to that particular service, it will get access. Otherwise, we don't share anything like that. Yeah. And we're actually going to a different model right now where all our passwords and everything are in config maps. However, we wanted to be able to also put the config maps within our repositories so we can version control them as well, but then we have passwords in there. So what we were going to do is actually create a config map that's specific to passwords only that go in their own repo, and then the application-specific config maps are pretty much wide open that don't have any security type of issues that would be an issue if you had put them in a repository. So did you have anything to add?
Just briefly follow on, I mean, and I'm sure it's kind of a given. We have not actually been audited yet, so it's going to be kind of an open question as to what happens.
Yeah.
It's right now kind of a question of following best practice. So yeah, definitely segment all your account stuff. Of course, we get the freebie of not having to deal with credit card data, so that definitely does help. But they're going to want to know. So I think that'll be an open question for next year.
Well, actually, I think we're going to get audited this year. I think we're going to actually go through that process. So. Maybe next KubeCon I could give you a better answer. I don't know. Anything else? Any other questions? Yes. So the question was, all the clusters that we have, Mongo, the Kafka, all that stuff, are they all containerized within Kubernetes? Yes. Everything is containerized. Everything is an ephemeral container. Everything is running in Kubernetes. Everything is scheduled through Kubernetes. Yes, we do have MySQL. And then the question was, do we have any relational databases? Yes, everything is on. Yes, everything is on. That was what we were trying to do. We were trying to make it so that literally everything runs within Kubernetes so that we don't have to worry about anything, really. And that was why Cloud Foundry actually didn't work out for us, because they couldn't do that for us. So I think you wanted to add. Oh, sorry. All right, we're done.
Thank you, everybody.
Thank you.